All right, let's do this geometry. Here we go. I think we're on page 13. No, that was last lesson. School is rocking some tunes today, so that's cool. Sounds like Santana kicking us off. We'll see if I can play Name That Band. All right, measuring dilations. Let me go hit the light. Back on me, baby. All right, dilating out. Oh, yeah, I'm supposed to do the cool down first. All right, let's do the cool down first, in case you're studying for your test. All right. Yeah, let me zoom this out a little bit. All right, cool. Get a bunch of tools. Telling you, get those geometry kits. They will help you. Okay. Triangle P prime, Q prime, R prime is a dilation of triangle PQR. Where's P prime, Q prime, R prime? Who knows? They didn't draw it for us. But anyway, P prime, Q prime, R prime is a dilation of this one using center C and a scale factor 1.5. So center C, scale factor 1.5. This is not pictured. This is, I'm gonna use center C. We're gonna make this thing 1.5 times bigger. So, is triangle P prime, Q prime, R prime larger or smaller than triangle PQR? It is larger. So instead of just writing larger, this is where you could say P prime, Q prime, R prime is larger than triangle PQR. Start getting in the habit of labeling things. How do you know? I know because who knew math was going to be language arts? But you know because the scale factor is greater than 1. What is the length of segment P prime Q prime? And explain how you know. Well, there's PQ. So PQ times your scale factor will equal P prime Q prime. This goes back to A times San Francisco 49ers equals A prime. Same thing. We're just doing lines. So 5 times 1.5 equals P prime Q prime. This is where you get a calculator out. I just so happen to know it. P prime Q prime equals 7.5. And that's it. Hey, what up, Len? All right, let's go to 3.1, dilating out. Oh, sorry, I'm doing a video. So 3.1, dilating out. So we got to dilate this triangle FGH using center C, scale factor of 3. So easy peasy. You just got to measure. So step 1 is measure CF, CG, and CH. I'm going to use millimeters just for extra precision. Millimeters help for precision. All right, so CH, here we go. So you put the little hash mark right in the middle of C. go to H. So there's 1 and 1.25. C to H is 1.25. C to G, well, let's just go one by one. So 1.25, well, we'll see about that. Let's go C to G. Let's do one thing at a time. Gotta remember that. Okay, C to G is 1. It's right on it. CG equals 1. These aren't millimeters, these are centimeters. What am I doing? 1.25 and 1. C to F is 1, 2, 3, 4, 5, 6, 7, right between 7 and 8. That's 0.75. All right. Let's do our equations. So CF, CG, CH. Here's what you do. You go 0.75 times 3 equals 1 times 3 equals 1.25 times 3 equals 0.75 times 3. If you had a calculator, you would get 2.25. 1 times 3 is 3. 1.25 times 3 is 3.75. Now these are going to be CF prime, CG prime, and CH prime. So it's still A times scale factor equals A prime. We keep going back to this. So let's do it. Now, I got a little out of control here. Should have done my math elsewhere, but anyway, CH prime, 3.75. There's 3. There's 3.5. 3.75 is going to be 1, 2, right in between 2 and 3, right there. Let's put a big old point right there. We're going to call that H prime. Now, CF prime is going to be 2.25. So we just go through F. Okay, here comes an announcement.
Can you come to the library, please? Miss Danica, can you come to the library? Thank you.
There's 2.5. 1, 2, 3. Just right there. This is going to be F prime. And then let's go CG. So CG was 3. CG prime, I mean. There's G prime. Let's connect our dots. It's Halloween, what do you know? We're supposed to be algebros, whatever that means. Okay, there's your dilation, scale factor of 3, center of C. Done and done. All right, let's move on to 3.2. Here's the center of dilation and a triangle. Measure the sides of EFG to the nearest millimeter. Okay. That one is 2.9 right here. So this one's 2.9. Then we got this one, which is 1.5. 1.5. And lastly, oh, we got another, a little bit less. I'm gonna say 2. Yeah, it's gotta be. They probably did a nice isosceles triangle. No, illustrative. All right. Assign you a scale factor. Let's just do a couple things. I want to draw a couple dashed lines. See how far I get. Still got like 10 minutes. Just doing some dash lines here from the center to each vertex. All right, let's measure these two. That one's 2. Guessing this one's 2 also. Yep. So that's 2, 2, and oh, that's 3. What do you know? Okay, so this dash line is 3 centimeters. This one's 2. This one's 2. All right, let's just start doing some dilations. Let's go twice as big. So instead of 2, it's gonna be 4. This would be dilation of 3, or scale factor of 3. This would be a scale factor of 4. So since we have such nice measurements, let's just do that. All right, let's go double. There's 6. There's 9. Here's 2. Double it. Triple it. Quadruple it. Okay. So we got some points. All right, let's do this first one here. Okay, so this is a scale factor of 2. This big one here is this one here is a scale factor of 3, and this one is a scale factor of 4. So we did 2, 3, and 4. How does your prediction compare? Oh, so the other thing you want to do is you got to measure this one. So it should be 5.8. This one's 5.8. This one should be, what's 29 times 3? Should be 8.7. Yeah, close enough. 8.7. This one's gonna be what, 9? This one's bigger actually. 3, 12. Yeah. So you're gonna notice that all the sides increase. Hey, what's up? Sick costume. So whether or not you go this direction, measuring from the center to each vertex, or you just take the side lengths and times it by your scale factor. In all instances, the sides change by a scale factor of 2, 3, and 4. So do the measurements to each vertex. All right, what stays the same? I got one more problem, and I gotta get ready to teach. But dilate quadrilateral ABCD using center, P, and your scale factor. Let's just say it's 2. So what do? You measure P to every single vertex. So P to A is 4.25. 4.25. So we're going to say 8.5 is going to be A prime. P to B, peanut butter, is 4.4. So we're going to say 8.8 is B prime. Let's go P to C. Politically correct is 3.5. So we're going to double that to 7. There's C prime. And then let's go PD. Professional development. That's 1.5. So D prime is going to be right there. So D prime. Okay, so you got a scale factor of 2. What did I do? I measured from our center. It's Halloween, it's gonna be loud today. Measured from our center to our vertices. And then I multiplied those measurements by 2. Last but not least, connect all the points. All right, so P to A was 4.25. So PA prime was 8.5. So 8.5 over 4.25. What about PB? That was, P to B was, P to B was 4.4. And PB prime is 8.8, so 8.8 over 4.4. Let's go PC prime. PC prime was 7. PC was 3.5. Let's go PD prime. PD prime was 3, and PD was 1.5. So what is 8.5 divided by 4.25? What is 8.8 divided by 4.4? 7 divided... They all equal 2, which was our scale factor. So that all stems from this. A times scale factor equals A prime. This is what I've been teaching you. Just solve for your scale factor. You just could divide both by A, divide both by A. These cancel out. Scale factor will always equal A prime over A. And that's exactly what we found out there. All right, can you prove your conjecture? Boom, up here. Complete the table. BA prime is 6. BA is 3. CB prime is 6. I'll bet you CB is 3. Yep. Let's go DC prime. What do you want to bet? 6. Yep. 6 over 3 and 6. They're all 6 over 3. It also equals 2. So whether you measure the sides and compare, or center to vertex and compare. So you pick one street. This one we went center to each vertex. They're twice as long. We just did that in the table. Or you measure the sides, the primes divided by the pre-image, the non-primes. In all instances, they end up equaling the scale factor. So what do you notice? What does the reasoning also prove? Well, let's take a look at our formula. A times scale factor equals A prime. It works for the sides too. So you could say like B prime, A prime times your scale factor equals B A. Just gotta divide by B prime, A prime, divide by B prime, A prime. These cancel out, so, divided by B A. B prime, A prime over B A. So in all instances, the scale factor ends up equaling like B prime, A prime over B A. Or, in other words, this one. So, all right, that's it. Good job.